Hello, welcome to the podcast for the Practice Exam 3 multiple choice solutions. So in this, I'm just going to go through the multiple choice questions on the practice test, kind of give you a little bit more explanation for why the answer is what it is. This will be broken up into a couple of different parts just so it loads a little bit easier, but let's go ahead and get started. The first section is economic epidemiology. Question 1, which of the following best represents the excess burden of disease? So the answer here is going to be D, in response to the COVID-19 pandemic. Many businesses have shut down in response to stay-at-home orders, leading to massive increases in unemployment. So the excess burden of disease is basically the efforts that you make to avoid getting the disease. And so the stay-at-home orders, the sort of social distancing stuff that we're doing, is all the efforts that we're making to avoid getting it. This is not to be confused with the epidemiological cost of the disease, which is the cost of the disease when you actually contract it. So that would be like the sickness that you get, the potential death that you get, any kind of like hospitalization bills, the pain and suffering that you would have from all that. So the excess burden, again, is the effort that you make to avoid getting it. Question 2. Which of the following best represents the relationship between disease severity, epidemiological costs, and the excess burden of disease? And the idea here is that a disease becomes more severe, the excess burden is going to go up because people are going to make stronger efforts to avoid getting it. And as they make stronger efforts to avoid getting it, fewer people are going to have the disease. And so the total epidemiological costs are actually going to start coming down. So even though the epidemiological cost per person is quite high for a very severe disease, the total cost is pretty low because people are making such efforts to avoid it that very few people end up having it. So the answer there is going to be B. Number 3, how do economic models of disease differ from standard epidemiological models with regard to disease prevalence and people's reaction to the disease? And so the answer is going to be A. In economic models, we assume that, yes, as diseases become more prevalent, people are going to take more actions to avoid getting the disease. But then we also need to look at the other side of that equation, which is as disease prevalence falls, people tend to become a little bit more complacent and they're actually going to reduce their protective measures. And so this is one of the reasons why it's really difficult to completely get rid of a disease in an economic model, because as that disease becomes rarer and rarer, you're going to have fewer people that are going to make efforts to avoid getting it, fewer people are going to get vaccinated against it. And so that's really the big difference between an economic and an epidemiological model, is the epidemiological model only looks at the first half of that, is that more disease prevalence leads to more protection. The economic models say, yes, that's true, but also less prevalence leads to less protection. And so we have this sort of feedback loop where the disease is almost never completely eradicated. Question 4. Which of the following is consistent if the prevalence elasticity of demand for self-protection is estimated to be 2.0? And so basically this is how much people are going to respond to an increase in disease prevalence in terms of the protective measures that they take. And so if prevalence elasticity is 2.0, which is an elastic sort of measure, it's more than 1, what that means is that a 10% increase in disease prevalence leads to a 20% increase in self-protection. And so, again, that's good in the sense that as that disease becomes more prevalent, people are going to take really drastic actions to avoid getting it. But then we also need to think about what happens if there's a 10% decrease in disease prevalence. That's going to lead to a 20% decrease in self-protection. And so prevalence elasticity means that people are going to respond really quickly to a disease, but then they're also going to stop taking such protective measures when that disease prevalence goes down. Question 5. Consider the SIR model of infectious disease. Suppose there's a decrease in the birth rate such that lambda sub b falls. Basically, that's just our notation for the number of babies being born, or the rate at which babies are being born into the susceptible population. And there's no other changes that occur. So basically, if there's a decrease in the birth rate, that means the susceptible population is going to be going down. There's fewer people in the susceptible population simply because there's less population growth. And if there's a smaller susceptible population today, that means that the infected population in the future should be smaller, simply because there's fewer people that are susceptible to the disease that can be infected. And so the answer there is going to be A. Question number 6. Which of the following best characterizes the relationship between vaccination rates, vaccination price, and disease prevalence? And so this is when we solved the model and we made the steady state predictions. One of the predictions was how the vaccination rate is going to change related to several variables, including the vaccination price and disease prevalence. And what we found is that the vaccination rate is going to go down as price rises. And so vaccines are a normal good. As vaccines become more expensive, fewer people are going to want to get vaccines. And so there's that relationship. That should make sense. And certainly, as long as there's some positive prevalence elasticity for self protection, which we assume that there is, then as the disease becomes more prevalent, more people are going to take measures to avoid getting the disease. And we'll see an increase in vaccination rates as disease prevalence goes up. Okay. Question 7. Which of the following best characterizes the relationship between the infection rate, the disease's inherent infectivity, beta, and disease prevalence? And so the answer here is going to be B. The infection rate rises with both inherent infectivity and disease prevalence. And if you just think about this logically, a disease that's more infectious than another one is going to obviously lead to more infections, all else being equal. And then a disease that's more prevalent, meaning that there's more infected people, should also lead to a higher infection rate because there's more people around there that have the disease that are able to spread the disease. And so we see the infection rates going up with both of those variables. Question 8. In the steady state, which of the following would cause the size of the susceptible population to rise? And so what we found was that the susceptible population is increasing in size as the size of the infected population goes down. Basically, anything that causes the infected population to decrease in size will increase the size of the susceptible population in the steady state. And of these basically 3 options that are there, the only one that actually will cause the size of the infected population to go down will be an increase at the rate at which infected people die. Essentially, what's going on here is that if infected people are dying at a faster rate, then they're not able necessarily to infect as many other people. The susceptible population is going to be larger simply because it's not being reduced by susceptible people becoming infected and moving into that infected population. Question 9. Suppose the government decided to subsidize the price of a vaccine. Under which of the following situations would the vaccine subsidy be most effective at reducing the size of the infected population? And so this is, again, one of the predictions that we found from the steady state is that the vaccine subsidy, which effectively is going to lower the price of the vaccine, is going to be most effective when, in these cases here, C, prevalence elasticity is low, such that people are less likely to become complacent about protective measures when the disease prevalence falls. And so the idea here is that as people get vaccinated, the disease is less prevalent in society and the population. And we want people to still get vaccinated even when that disease isn't as big of a deal. And that's going to be happening when the prevalence elasticity for self-protection is relatively low, that people are not really responsive to how present the disease is in terms of the protective measures that they take. And if we go through these other options here, A, demand for the vaccine is not responsive to changes in the price of the vaccine. Obviously, a vaccine subsidy would not be effective in that case because that means that people aren't really factoring in price that much in their decision to get a vaccine or not. And so lowering the price wouldn't have that much of an impact. B, the inherent infectivity of the disease is high. Basically, if the inherent infectivity of the disease is high, then a vaccine is not going to be that effective because a lot of people are going to get infected before they become vaccinated. And then D, if people are very responsive to disease prevalence, then what that means is that, yeah, sure, they're going to take drastic preventative measures when prevalence is high, but that also means that they're going to back off of those measures at a pretty high rate when prevalence goes down because of vaccination. Okay. Number 10, which of the following best characterizes herd immunity? So herd immunity basically is happening when the reproduction ratio of a disease is below 1, meaning that each infected person is infecting less than one person on average before either they recover or they die. So essentially, the disease kind of dies out in that sort of situation because the infected population is unable to grow because each infected person is not infecting at least one other person, one other susceptible person. And so the answer there is going to be C. Going through the other options, basically, obviously, A is the opposite of that. B, the disease is completely eradicated through universal vaccination. I mean, that's great, but that's certainly not the definition of herd immunity. And then D, the sort of inequality that's given there, herd immunity occurs when the opposite inequality is there, basically when beta times the size of the susceptible population is smaller than the rate at which people are leaving the infected population. Okay. 11, why might a government subsidy for vaccination be more desirable than imposing a tax on people that spread the disease? And the answer is going to be all of these. Basically, it's difficult to monitor all infectious behavior. So if you're going to tax infectious behavior, you need to be able to observe it. And if it's difficult to monitor everything that people are doing, how are you going to tax everything? Such a tax would certainly be difficult to enforce, given that some behavior is more infectious than others. You know, is getting on an airplane when you're sick, is that more infectious than, going to work? For example, how would we set these taxes to perfectly sort of incentivize people to take the correct actions? It's going to be kind of difficult to figure out, what taxes to levy here and there. And certainly this is going to be a regressive tax because the people that are sick, the ones that are paying the taxes, oftentimes are also suffering from other economic burdens. They're sick, maybe they lost their job, they're unable to work. And so we don't want to impose the highest costs on the most vulnerable members of society. And so the answer here is going to be D. All of these are reasons why a subsidy may be preferred.